Now that we understand the concepts, we turn our attention to the NAT command line configuration. In icnd2, we configured NAT through the SDM, the GUI, and that was as simple as next, next, finish, and we were essentially done. Now we're going to do it from the command line where we have complete control over exactly how NAT is going to operate. Of course, with control comes complexity, so we'll start off with the most common form of NAT, which is configuring NAT overload. Once we're done with that, we should have clients in our network that's able to access the internet. From there, we'll be able to configure static NAT, which will be used to host some internal servers on our network from the outside world. Last but not least, we have configuring dynamic NAT with overload. This is something you would do in a larger network to allow multiple internal clients to translate out to the internet to a pool of addresses that can be overloaded themselves, meaning once you tap all the port numbers that are available on one IP address, it can move over to a second one. As we do our configuration, most of our focus will be on router 1 because that's where all the action's happening. This is the router that's doing NAT. Now I want to go in and just test a few things and do some proofs to make sure that our internet routing is working okay and our normal routing is working okay. I'm going to go up to router 1, and what I'm going to do is on router 1, I'm going to ping the ISP to make sure I'm getting there and make sure I'm getting out to the internet. So on router 1, I'll just do a show IP interface brief. There's my public IP address. I'm going to ping 171.97, which is my ISP. Oh, and sure enough, it's working. Now I'm getting some pretty slow response times because I have a massive file upload going on in the background. So we're not really concerned about performance right now. I'm just wanting to make sure I'm connected. Now let me ping my favorite IP address in all the world, 4.2.2.2. That is a public DNS server out on the internet, and I can verify my routing table. I have a default route. It is going to my ISP. Obviously, that default route is working right now because I'm able to get to that DNS server. By the way, here's a tip of the day for you. If you ever want your router to use a name server, you can type in IP name server 4.2.2.2, and then I'll type in IP domain lookup, which turns on name lookups, and then you can actually ping things like google.com. See that? It says translating. It went to the DNS server, and there's Google's IP address. If you don't give it a DNS server, it won't be able to resolve those names to IP addresses. So you'll always have to ping by IP address. So that's pretty cool. All right. So we know we're connected to the internet. We know that our router 1 can even get to Google, for crying out loud. So let's now do some other tests. I want to make sure that router 1 can get to router 2, and specifically I'm going to be working on this host down here. I have a connection to him in the Cisco lab, so he is going to be our internet host. So let's make sure that we can ping that host. I'm going to go to 192.168.10.50, and what that's going to do is come into router 1 on fast Ethernet 0, flip back around on our router on a stick, out fast Ethernet 0.10 into the switch, and hit this host. So let's even go one step further. I'll do trace route 192.168.10.50. That was the IP address, right? 192.168.10.50. All right, good. And sure enough, there we go. It went through router 2 and then hit that host, 10.50. So I am able to ping that host. Now I happen to have a remote desktop connection to that host right here. Let me bring it in the picture. Actually, let me just kind of shrink things down, get my QuickTime player out of there. And I'm going to do an IP config. And there, yep, this is the host, 10.50. I'm going to make ssure that I can ping 192.168.10.1. It's good. And let's even do a trace route to 192.168.1.1, which is my internet router, router 1. And just verify. Gotta love it. I'm going to do trace route -D. Windows always tries to look up names, which makes it hang there forever. So, and what I mean by names is trying to figure out what domain name 1.1 really has, which it has none, so it hangs there for a long time. So -D ignores that, and you can see it went through router 2, 10.1, and then reached router 1. So I am getting to router 1. So let's go ahead and do a trace. Let's see if this host can get to our same DNS server. Oh, hang on. -D. All right, went through 10.1, went to 1.1, and I'm dying. asterisk, asterisk, asterisk. It's just going to keep on asterisking, meaning as soon as it got to 1.1, it died. Now, if I were to actually pull out a packet sniffer right now, I would see these packets coming from this host. They'd be coming up through router 2, going out, back up through router 1, and they'd be actually getting sent out to the ISP. But remember, it's going out without NAT right now. The ISP is getting a private address and it's saying you are denied. You are not allowed to come into the internet because all ISPs block private addresses. So what I have to do is I have to NAT my private address to a public address so that it is able to go through and look as though it's coming from 171.98. Now that goes back to all the NAT concepts we talked about in the previous video. So we can see our request is getting nowhere. So I'm just going to cancel that guy and shoot back up over here. Let's go to router 1 and implement NAT. You can see my steps to configure NAT overload. That'll be the first one that we implement. A flyby review, NAT overload is the one that allows many internal hosts to share the same public IP addresses by using port numbers to distinguish between all of them. And we'll see that happen before our very eyes with our client in VLAN 10 down here. So here's our steps. Number 1, label the interfaces. We need to identify which interfaces represent the inside network and which one represents the outside. Second, we need to tell router 1 what is the valid internal IP addresses to be translated. We do that by using a access list, and this is why this video is after we talked about access lists. I'll show you that in a moment. Finally, we turn on NAT overload. So here's what I'm going to do. I'm going to go step by step. Number 1, label the interfaces. On router 1, this is actually the easiest step. I'm going to look at my interfaces. I see Ethernet 00 and 01. 00 connects to the inside of my network, so I need to go under that interface and type in the command ipnat inside. That tells the router that is my inside interface. I'll go under interface Ethernet 0/1, which connects to the outside of the network, and you probably are thinking what I'm thinking, ipnat outside. That connects to the outside of the network. That's it. That's step 1. We've labeled the interfaces. Second step, identify internal IP addresses to be translated, meaning I need to tell my router 1 which IP addresses should be translated and even what IP address shouldn't be translated. Maybe I don't want internet access for these guys. Well, I could prevent them with an access list from getting out there, or I could just deny them from getting NATed out to the internet. I do this by using a access list. And I am going to use a named access list. It is much easier for me to identify. I'm going to type in IP access list. And it says, what kind of access list? Well, I would like a standard. Remember, a standard access list only allows you to permit or deny based on source addresses. Now, we've been thinking about access lists up till now as permitting or denying access, like you are denied from going through this router completely. But in this case, we're going to set up this access list to permit or deny people to be NATed. So here's what we'll do. We'll go ahead and say access list standard, and we'll name it. You can see word. What name would you like? The word will be NAT addresses. I always type my names in all capitals so I can identify them in a running config pretty easily. Now underneath here, I'm going to do my permit and deny statements. I'm going to say permit. You know what? Just for this example, I'm going to permit everybody to be NATed. You know what? Except, just for fun of it, I'm just like I had my arrow pointed over here. I'm going to deny these people from being NATed. So I'm going to put my deny first. I'm going to say, instead of permit, deny 192.168.3.0, 0.0.0.255. That's my wildcard mask. So the first thing I'm doing, I'm denying these guys from being included in the NAT addresses or addresses to be NATed. Now, I'm going to go in and do a permit after that. 192.168.0.0. 0.0.255.255 is my wildcard mask, which says match everything that starts with 192.168, and I don't care what comes after that. Now, because this is an ordered access list, I'll do a show access list. It's going to deny these people first if they come in. But if you are not, this essentially says if you are not 192.168.3.0, but you are anything that starts with 192.168, then you are permitted. That's my second step. I have now created an access list which identifies internal IP addresses to be translated. Now the last step, enabling NAT overload. I can enable NAT overload by using the NAT command. And this is the biggest command that we have with NAT. And trust me, it will look confusing at first, but I'll explain it in English. I'm going to say, in global config, IP NAT. Essentially, I want a NAT. The router's going to ask me, well, how do you want a NAT? I want a NAT from the inside of my network outside. And I'm going to say, based on the source address translation. The source addresses that I'm going to translate are going to be an access list. You can see access list describing local addresses right here. An access list, and it says, well, what's the name of the access list? That name is NAT addresses. Oops, I didn't paste the whole thing. There we go. NAT addresses. That's the list that identifies. And it says, well, okay, do you want to send that to a pool of global or public IP addresses? Or do you just want to specify what interface those are going to be going out and use the interface IP address? Well, in this example, for simplicity, I'm going to use the interface. I'm going to say, go ahead and send them out interface. And let's look back at our diagram. Ethernet 0/1 is our public interface. So I'll say interface Ethernet 0/1. And I'm going to follow that up by saying, please overload, meaning please allow multiple internal hosts to share this one IP address. So let me hit the up arrow on that command, go back to the beginning. I'm going to read it to you in plain English. IP NAT says, I would like to NAT. And the router says, well, how would you like to NAT? I would like to NAT from the inside of my network to the outside. The source addresses that I would like to NAT are identified in the access list NAT addresses. Anything that's permitted by that access list is going to be permitted to be NATed. And I would like to NAT them out interface Ethernet 0/1, and please overload that address. You can see it's cut off here at the end. Please overload that address because if I don't include overload, only one host will be able to get out, and then it will say, okay, you've used up the address on interface Ethernet 0/1. Nobody else can use it. So use overload. Now I know that's a very long line of syntax, but unfortunately that's the command you have to type in, and we'll keep seeing that as we look at the different forms of NAT. So at this point, our host should be able to get out. Ready to test it? Hit that up arrow. Let's do a trace route. Goes to router, goes to public IP address. Oh, look at that. Look at that. Ew. It's getting out. We have it going to router 2. It goes to router 1. It then goes to the next hop IP address, 68.110.171. I think I killed it. There we go. It's still going. It's trying to get to 4.2.2.2. It's going around the whole internet right now, trying to get to our DNS server, and finally it gets there. The ultimate test, of course, is to open up a web browser on our client. Oh, look at that beauty. I'll shrink it down right here and verify that our little client right here can go to the best site in all the internet. It's the Cisco blog. No, cbtnuggets.com. And I know my internet connection is bogged down right now, but there in the flesh is CBT Nuggets. Now check this out. I'm going to take this another step and start verifying. Now on router 1, we now have NAT translations going through. Watch this. I'm going to do show IP NAT translations. Oh my word, look at that. Look at this. Look, okay, look at this. You have inside local, right? Inside local identifies the address inside of your network. And if you were to diagram this, the inside local addresses represents these guys. I'll put IL. IL, anything that is inside, and local, it's a private IP address inside of my network. Inside global, I always say inside means whose control is it under? It's under my control. Global versus local, that's public, or global is public versus private. Look at what's happening here. My client, you see 10.50, is being translated to a 68.110.171.98. That is the public IP address on router 1. It's being translated to that, and notice it's using that source port number to translate it through. Now notice it's going from the inside private to the inside global. That's the public address. Then outside local and outside global. These will always be the same if we're doing this kind of NAT translation. You can see that it's going to this IP address, that IP address, this IP address, all these different IP addresses on port 80. That's the destination port. That's our web surfing port. Initially, when I opened my web browser, it went to Firefox, the little Firefox homepage. Hang on, where do we go? We're right here. And it went to this page right here. Now, this page is comprised of a graphic, a little Firefox guy here, a Google search field. We got some customization options down here, images, maps, blah, 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 blah. So when you're seeing these translations, we went to one website, but we were probably redirected and got information from many different websites. That's why we see all these translations, even though we only went to google.com and cbtnuggets.com. So all these are the different websites. And as time passes, you'll see that they are timing out. They're slowly fading because the connections are being severed. You also notice I have an ICMP message. That's my ping that I did to 4.2.2.2. When I tested that, when I did my trace route to get to that server, it was using ICMP, the ICMP protocol, to do that. Isn't that amazing? I don't know. NAT always blows my mind. This NAT overload concept. I could go in there and I'm trying to think. What else can I do? That's it. That's NAT. It's working. So all of these different clients on my network are able to get through except this one. This is what I wanted to emphasize. 192.168.3. Whatever will not be allowed to get through. And the reason why is because the access list denies them. To simulate that, I'm going to go over to router 3. Let's do a show IP interface brief, my little alias here. And I'm going to type in on router 3. Well, first off, I'll do ping 4.2.2.2. Sure enough, router 3 can get there. And you might be thinking, well, I thought router 3 was denied. Well, it is if it's coming from an IP address on this LAN. But router 3 came from 192.168.2.2. Matter of fact, let's check it. Jump back to router 1. Show IP NAT translations. And right there. Notice 192.168.2.2 was using ICMP to ping that DNS server. So that was allowed to get through. Let's try this. You go back to router 3 and do a ping 4.2.2.2, but I'm going to follow that up with a source interface of, oh, what interface was that? Ethernet 0/0. That's the one that connects to the LAN. Ethernet 0/0. Now you can see we're dying because it's pinging from a source address. It's coming from a source of 3.1. And if I were to jump over to my router 1 and do a show, let's do a show access list. You can see my NAT addresses. 10, sequence 10, denied 192.168.3.0, and I've had 5 matches. 5 pings that came from router 3. The permit, everything else that started with 00, had 23 matches. Those are being permitted to be NATed. Now, I want to make sure we catch something here before I move on to the other forms of NAT. When I created that access list to identify the internal addresses to be translated, that's exactly what it's doing, permitting or denying them to be translated. Router 3 is coming out here. It's going tukka, 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 all the way through the network when I pinged from this source of 3.1. And router 1's getting it, and it says, you are denied from being NATed, not denied from being routed. So router 1 is sending those packets out from router 3. When I did this little, oh, I did it again. My screen jumped. I don't know how I do that. Hang on, let me see if I can fix this here. When I went into router 3 and I did this ping right here from a source of 3.1, 3.1 was allowed through. It was just denied from NATing. So if I were to go to my ISP, if I had some kind of packet sniffer at my ISP, I would see packets coming in from 192.168.3.1. It was not denied from routing. It was denied from being NATed. So I wanted to make sure I specify and emphasize that that's what that access list really does. All right. So that is NAT overload. Now let's talk about static NAT. Static NAT is what allows me to create mappings to let internal hosts be accessible from the outside. What I mean by that is right now we have a NAT barrier, which is a form of security in my network, meaning nobody can get into my network without first being invited from an internal host. Meaning if this smiley guy down here didn't go out to the internet and say, CNN, I would like your web page, CNN would never be able to come back in and say, here's a web page. So NAT, in essence, is an impenetrable form of security because the outside cannot access the inside. Now, I want to make sure I emphasize that NAT security is not the only kind of security that you can have. It needs to be combined with many things. It's not perfect security is what I'm trying to say. So what I can do is, let's say that this smiley host down here is a web server, and I want to allow people to access that web server from the internet. Well, I need to create a static NAT mapping that maps this host to a public IP address in order for people to be able to access them. Now, first things first, you need to make sure that you get public IP addresses from your ISP. As of right now, I have 68.110.171.98 assigned to that interface. But if I wanted to be able to have servers on the inside of my network, I would typically, or normally, I'll show you a way around this, but I would normally want to go to my ISP and say, ISP, I would like to get more IP addresses. And they will say, we will charge you this much a month. And you say, okay. And they will say, okay, you can have 68.110.171. 171.99 and .100. You know, these different IP addresses that you can use for your internal network. So let's say, just for ease of this example, and I'll show you some cool ways around this, let's say they gave us 99, right? And I want 99 to map to my internal web server. That's going to require a static NAT mapping. The way that I do it is I move to global config mode on my NAT router, and I say IP NAT. It says, I want a NAT. I want a NAT from the inside of my network. Now, I know you might be thinking, I thought that would be outside. I thought you were NATing from the outside to the inside. Well, you are in a way, and you could do it by typing IPNAT outside and then say this address to this address. But really, when you start working with NAT, it's best just to use one direction. When I say IPNAT inside, that says I'm going to NAT from the inside of my network out, which is true. But anytime you do that, you're actually creating two-way NAT mappings. So it will NAT from the inside to the outside, but it will also NAT from the outside to the inside. So you might wonder, well, why would I use NAT outside? Good question. I never do. As long as you learn one direction and get comfortable with that, you never have to use the other. You could also start with NAT outside, say I want to use NAT outside and use NAT outside for anything and never use NAT inside. I just always like using inside because it makes more sense to me. So I'm saying I want a NAT from the inside. It says, well, what do you want to translate? I want to translate the source address. When somebody comes in, and I'm going to make this a static NAT mapping. Notice it says local to global. Now, let me stop right there. If I would have said IPNAT outside, all it would do is say, well, you want to map global to local. So you would just type the outside address first and then the inside address second. Typing IPNAT inside lets you type the inside address or local address first and the outside address second. That's really the only difference between the two. It's just what direction are you looking from? What direction do you prefer? But functionally, they're the same. So this is going to be a static mapping. And I'm going to map the inside local IP address 192.168.10.50. That's my little guy down here, smiling guy. He's my web server. I want to NAT him to the outside IP address 68.110.171.99. That's the new IP address that my ISP gave me or sold me and allowed me to use on the internet as long as I'm using them. At that point, I hit enter. I've now created a static NAT mapping. Now, this is where I want to explain what I mean by two-way. Anytime this inside host decides I would like to access the internet, 10.50, he will go out, go to router 1, and go out and be seen on the internet as this address, 68.110.171.99. Likewise, anytime anyone on the internet accesses that address, 71.99, router 1 will get that and translate it back to the inside host. That's what I mean by two-way mapping. It goes in and it comes out. So let me do a show IPNAT translation. And you can see all my translations have timed out. This is a static. It says anytime somebody accesses that, it will become that. And anytime this one accesses the internet, it will become that and be sent out as that. Now you can see this doesn't have any IP addresses because as of right now, nobody is accessing that. Nobody is accessing this IP address right here. And so when somebody does, if somebody does access my quote unquote website, their IP address will show up here because they will be natted to my inside address right here. That is known as simple static NAT mapping. Now, I mentioned I was going to show you a way to kind of overcome this. Like, you know, let's say you're with a company and they only have one IP address from an ISP, and either the ISP will not give you any more IP addresses because some of them work that way, or the company does not want to buy any more IP addresses because it can get kind of expensive. What we can do is we can use the IP address that we have on our public interface right here, the 68.110.171.98, and use it as somewhat of a static NAT mapping. Let me show you how this works. We're right now using this for NAT overload. And let me first go in. I'm going to remove this static NAT mapping. No, put a no at the beginning. So that one's gone. Go back, verify. Show IPNAT translations, we've got nothing. All right, we've removed our static NAT mapping and we only have one IP address. And I would like to use that IP address to still allow access to the web server. Well, as of right now, that IP address is being used for NAT overload. So as hosts surf the net, they're going to be seen as that IP address. So I can't statically map that whole IP address to the web server. This is what we know as static port mappings. Watch this. You may have seen it when I was doing the command before. I'll type in IPNAT inside source static. This is same thing as before, same command, but I'm going to hit the question mark. Now, when I did the last example right here, I typed in the private IP address. Now I'm going to do something a little bit different. I'm going to type a protocol. I'm going to statically map TCP to the inside local, the private IP address, 192.168.10.50, and I'm going to map port 80. To the outside global, it says, what is the global IP address? 68.110.171. Or wait a sec. I'm not going to do that. I only have my interface, the IP address on my interface, right? 68.110.171.98. So instead of mapping it to a different global IP address, I'm going to map it to the IP address on the interface. And I'll say interface Ethernet, what is it, 0/0? 0/1. 0/1, question mark, port 80. Do you see what's happening here? What I'm doing is anytime my outside interface, 0/1, my internet-facing interface, gets a request on port 80. Now, what's TCP port 80? Web services, right? That's HTTP. It will translate that request to the inside IP address, 192.168.10.50, on its port 80. Huh. That's pretty hot. Because now, when I go back here, I'll do show IPNAT translations. I can see that this translation is happening. Oh, it looks like we had some other, our little host went out and accessed a time server. But we're not going to talk about that. This is my static NAT mapping. I've got HTTP. Nobody's using it as of right now, but the host can still, let's bring my host back to the stage. Our host can still, let's go to www.ciscoblog.com. Only the coolest blog on the internet. And, you know, we're accessing the Cisco blog, minimize that guy, and, oh, wait a sec. Minimize this whole thing, come back here and do a show IPNAT translations. We're still accessing the internet, we're still overloading, but we're now borrowing one port from that public IP address and giving it to that host. Now, this gives us a lot of flexibility, guys. Look at this. I just assigned port 80 on that IP address. If anybody from the internet accesses that on port 80, it'll forward into my client, but I could totally split that address apart to access all kinds of things. Like let's say this is an email server, email, that I have inside of my company. That email services use TCP port 25, known as SMTP, Simple Mail Transfer Protocol. I could assign port 25 of that public IP address to a totally different internal host. I could split apart an IP address for however many services I really wanted to use. That's very powerful because with simple static NAT, you dedicate a full public IP to a full private IP, and you may only use one or two ports off of that. Well, why not use each public IP address to the max? That's what that port static NAT mapping is all about. So you can split it up in many different ways. So we've talked about NAT overload. We talked about static NAT. There is one more concept I want to show you, and this is for larger companies. It is dynamic NAT with overload. Now, as of right now, I'm going to do a show run, and I'm going to include lines that have IP NAT in them because I just want to filter it down. And there's my my command that I typed in to NAT the private IP addresses in that access list to the interface and overload it. That's NAT overload. But I'm going to remove that. I'm going to do a copy, global config, put no paste, and paste that in there. It says dynamic mappings are in use. Do you want to kill them all? It means there's some people using that right now. Are you sure you want to do that? Yep, sorry. Internet has gone down. So we now have a clean slate, and I want to show you how you can configure dynamic NAT, meaning multiple public IP addresses using NAT overload. What I can do is I can approach this a little different. Instead of using the public IP address on the interface, I can create an IP NAT pool. You can see I can type IP NAT pool. It says, what would you like to name it? I'll say public addresses. Do a space question mark. It says, what start IP address would you like to put in that pool? And I'll say, well, let's say we purchased IP addresses from our ISP, the 68.110.171.99 and 100. I'll put 68.110.171.99. And the end IP address will be 68.110.171.100. Those are our public IP addresses that we've gotten. To a question mark, it says what you can either type in the net mask, meaning the decimal subnet mask, or the prefix length. What it means by prefix length is what bit notation, /24, /32, that kind of thing. I'll just put, it's only looking for the number. So 24, which means it's a class C subnet mask. Or this is a preference. You can also use the net mask option and type in the decimal subnet mask, 255.255.255.0. Okay. So what I've done is I've created a NAT pool of 2 addresses. Now I can use that same command that I used before. I'll type it in again. IPNAT inside source to turn on NAT overload, right? I'm going to do a source list. The access list was NAT addresses. Right, that was the access list we created. I want to NAT from that access list. Now before, we were going specifically out in interface, using whatever public IP address we had on that interface. The advantage of that is it's very simple, and you only need one public IP address. The disadvantage, well, there's no real disadvantage, but the problem is if you have a very large company, it will eventually run out of ports. Meaning as you get hundreds and thousands of hosts on the inside of your network surfing the internet, this will run out of ports that it can use on that public IP address, and it'll start killing NAT sessions, and people will kind of lose their connection to the internet from time to time. So what we can do is give a pool of 2 public addresses that we created. So I can say, go ahead and use that pool. When one of them is full, meaning there's enough people using that, switch over to the next one. So if I wanted to do that, I would just say, I want to NAT. I'll read this in English. IPNAT. I want to NAT from the inside of my network that is identified as the source IP addresses in access list NAT addresses. And I want to NAT them to the pool of addresses that I just created. The name of the pool is public addresses. IPNAT pool, public addresses. And then I would like to overload that pool. If you forget the overload keyword, what's going to happen is it's going to allow 2 people meaning the two public addresses that you have to access the internet, and they'll say, sorry, we're out of public IP addresses. That is known as dynamic NAT with overload. You're dynamically going from a group of addresses to a group of other addresses, a group of private to a group of public, and we're overloading it, so when one of those public addresses get full, it will fail over to the second one. That is NAT in all its flavors. Still to this day, I think NAT is one of the most fun configurations that you can do on a Cisco router. I don't know why. I just think it's such a neat concept. So let's wrap things up. We saw configuring NAT overload. That was the first thing that we did. Labeling our inside and outside interfaces, creating a private IP address access list, or what addresses we would like to translate, and then combining all that in the IP NAT command to enable overload. We then configured static NAT to allow outside access to our internal IP addresses. And then finally, we saw dynamic NAT, which is going from private IP addresses to a pool of public IP addresses. And we combined that with overload so that when one of them ran out of port numbers, the other one could take over. I hope this has been informative for you, and I'd like to thank you for viewing.